this is unashamedly a quantitative research presentation, so those that are qualitative, you can just put your feet up and relax. And also, you can see I've used the shortest title possible, and I give kind of a lot of information in there, don't I? As most published research findings are false, that's not provocative, and it's time to retire statistical significance. Most people are still using it, right? What are the viable alternatives? So there's kind of a lot to cover in this, and I'm deliberately positioning it in a way that is hopefully going to be provocative for those that use quantitative methods, and we'll just see how that goes. I did this on the couch a couple of nights ago, so I'm not quite sure how it's going to land in terms of the presentation, but we'll just see how it goes. I gave a bit of details about myself here because I'm not sure that many of you know this of me. I'm the Professor of Population Health currently here. I'm an honorary Professor of Biostatistics at the University of Queensland, but I was also the very first Professor of Biostatistics in New Zealand, an honour which is, something that I haven't really celebrated a lot, partly because the idea of biostatistics and biostatisticians has come with a very kind of compartmentalized idea, and I've always been a leader of research, but I've also been really interested in methodological things, and that's why you've landed here listening to me on this. It started off, as you can see, in my honours dissertation, my master's thesis and PhD were all in theoretical Bayesian methods. So if you open up my thesis, there's a few words, but it's mainly Greek. Honestly, when I travelled in Greece, it's brilliant because my math came in handy. I can read all the Greek signs and stuff. Really cool. So my theses at that time were around the conceptualization of methods that researchers might use for their research. In my role now, I balance that out by using applied research methods. And because it's easier and a bunch of reasons, I end up using the dominant paradigm, which is the frequentist methods, which typically rely on things like statistical significance. But in my heart, I'm a Bayesian. And I still publish Bayesian methods. And we can talk about that a lot, rather too much. So the motivation for this talk, there's a bunch of reasons actually. I was reviewing a paper, I do a bunch of that, and this paper, it was a research paper, it was an RCT, and they just littered it with hypothesis tests and p-values. Every page you turn, there is multiple. And so we'll talk why that sort of frustrates me a little bit. But I also, corresponding at the same time, I received an email from David. David and I used to sit together at high school and talk about things like mathematics. It turned out the teacher of our class was his father, who was a mathematician. He thought we'd both end up being mathematicians. And so, unfortunately, David went to the dark side and is now an anaesthetist. And he wrote to me saying this: in the critical care literature where he works, approximately 90% of published multi-center RCTs, these are replication studies reporting mortality, their outcomes are negative. So replication, multi-centered RCTs are typically created because there is a sentinel paper that shows a demonstration of a technique or an intervention that works. And then the idea is that you use a multi-center approach to try and replicate that. So this new finding has shown this whole big thing that might, obviously help intensive care. And then in the field, this is what David was saying, in the field, 90% of them he's seen are false, or they don't show the same effect. He also says the proportion that are negative seem to be increasing with more recent published studies. And in virtually all cases, the observed effect sizes, that is the treatment effect difference, the importance of the difference the treatment makes, are much smaller than the expected effect size that was published in the first studies. Obviously, that's got massive implications for delivery of healthcare. You're thinking about that. And 90% of them, and this is his anecdotal stuff, was shown to be. So what's wrong? That was his question. What is wrong? Why is this happening? Well, David's I know I can do this. What David is reflecting is actually been recognized within the literature. There is an increasing number of studies which aren't able to be replicated in the field. And there's lots of reasons for that. I don't want to spend a bunch of time talking about that. But this paper in PLOS Medicine goes through all the reasons for that. It's a really interesting paper. It's a good read. It's free and downloadable. So they give a number of reasons for why that is the case. One of them is this whole idea of statistical significance, which is the bit that I want to talk about. Our research, our dominant research paradigm that we use at the moment is called the frequentist method. And it has been argued that is a flawed statistical machinery. It hasn't been argued just recently, as you can see from this slide. It's been argued as being a flawed statistical machinery for a very long time. Professor Jim Savage in '63 published in the prestigious, and it is a prestigious, psychological review that Fisher's method, that is the method where we do this hypothesis testing and then calculate a p-value and then make a decision, is startlingly prone to spurious significant results. That should worry you. It worried me. That was in '63. Professor Dennis Lindley, and I had the real privilege of meeting Dennis in the UK. He reiterated that message during the '70s. And Professor Jim Berger, who was an Erskine Fellow here, he came here a couple of times. And again, I was fortunate enough to meet him. That was around my PhD sort of stuff. He published a series of articles, again, warning the astonishing tendency of Fisher's p-values to exaggerate statistical significance. These are all statisticians, right? Internationally renowned statisticians. So within the field of statistics, we've known this. And yet, in the field of medicine and healthcare, it doesn't seem to have penetrated terribly much, at least my experience. Now, there is a lot to be said on this. And I think the best way of doing it, or one of the best ways of doing it, is to just go to the YouTube address here and see this 15-minute clip by this guy, Michael Tan. He's given kind of some of the reasons why the p-value fails. He is a GP, so he does it in a very non-technical language without any of the cool mathematics that we heard from the other speaker just before. It's very much a reasoned approach. So if you are interested in some of the misconceptions about the p-values and how clinicians get it so wrong and they do it over and over again, I urge you to do that. I sometimes put this YouTube video in my class, but I've only got 10 minutes and it's 15 minutes, so I couldn't do it. This is another, I think, a really good paper to refer to, and this is in Nature, which is obviously one of the premier journals. It was written published in 2019, so it's been out a while, and it's been published by over 800 signatories at that time. It's thousands now. And these are the leading methodological people, thinkers and statisticians in the world. Some of you might recognize Sander Greenland. He's written the seminal book, co-authored it, Modern Epidemiology. So these are the big hitters writing around this. And what is this? Retire statistical significance. That is the kind of inlights in the Nature article. We should be retiring it. They don't say abolish it. They didn't go that far in this article, but they say we rely on it far too much in making substantive conclusions in our scientific studies. We should avoid it. Anyway, I'll let you read that. As I said, that's all free to download as well if you're interested. By the way, if you want to have a conversation outside of this session, I'm always open for that sort of chat as well. It all comes down to how we conceive probabilities. If I ask you, if I have a coin, and sometimes I bring a coin, but I don't at the moment. I've only got a pen in my pocket. If I have a coin in my pocket and I tossed it, what is the probability I'm going to throw it ahead? A coin you've never seen before. What is the probability? Can anyone give me a hint what it might be? Brad, how did you get to that point? You've never seen that coin before. Yeah, but you said 50%. You've never seen that coin before. How did you know it was 50%? Exactly. And do we do that when we're doing an RCT? Can we make those same assumptions? We can't. We don't use any of our history of the medication or the condition of interest in conducting the RCT. We don't look at the physical property, the biological property, or the historical property or anything. We don't invest any of that information in that. We go into that study agnostically, right? We don't bring any of that information. The question is, should we? And there's a bunch of things we could unpack on that. But our scientific endeavour is that we, at the moment, we try and do things, we pretend that we're away from the experiment, we look at it objectively, dispassionately, agnostically. I've got 2 minutes. I'm not going to do this, am I? I sped it up. It turns out that there are other different ways we conceive problems. You used logic, you used prior information. You are a subjectivist. You actually answered that as a Bayesian would. As a frequentist, you would say to me, toss that coin and then I'll tell you. That's what you do. Gosh, 2 minutes. Where am I going to go? What I might do is talk about Bayes, I suppose. Yeah, the common paradigm that we use at the moment is a frequentist approach. So we pretend we're objective and that experiments are a long-term thing, even though we've got one replicated over and over. A Bayesian view is that we take information from the experiment. We take information that we know from past similar studies, our own experience, the physics of the coin or whatever it is, and we integrate that to make a posterior distribution. And from that, we make all inferences. We don't do hypothesis testing. It's all probabilistic assertions, which I think is kind of cool because that's how I operate. For instance, and this is in that YouTube thing I put before, if we have a data set and we conducted an experiment, say maybe between whether or not drug A or drug B is better for the particular condition, and in the real world we had a significant result. The p-value of the study was 5%. Okay? We publish that, right? We'll probably get it published in June. We'd love it. But if we take a Bayesian approach, and we believed actually before we conducted this study, there was only 5% chance that that drug was going to be better. When we combine that information, in fact, the posterior says, well, there's only 11% chance at the end that that treatment was a better treatment. A true equipoise, if we believe ambivalently at the beginning the treatment could work or might not work with equal probability, even after the real-world data, there would still only be a 71% chance that the treatment was effective. This, in part, explains why we're seeing all these results that come in that actually, when we reproduce them in real-life settings, they're non-significant or they're null. It is only when we are 90% confident that our drug is better or our treatment's better, combined with the real-world data, that we get to this level of this magic 95%. I think it's kind of powerful. I think we're driven too much by p-values and significance. I think we should avoid them. And if you want a conversation about that, I'm your guy. Oh, yeah. The last thing, that's my brother. It's just we run together, and I just want to put that in. And I think it's important too. He's an orthopedic surgeon up, and he says, regardless of the scientific evidence, if I use a new prosthetic and I have a negative outcome, I'll not use that prosthetic again. You know, that's to say that expert opinion and decisions actually make a real difference. And we should actually integrate them a little well. Have I got 30 seconds? So Robert was he was a student of mine, and he was a clinician. And I told him about Bayes for the first time, and he just loved it, because then he went and wrote this letter to in the BMJ saying, well, he tried to do a consultation as if he was a frequentist, and how absurd that is. And he came to the idea that clinicians, we are natural Bayesians. We use that prior information, our experience and our training, together with empirical information, with what we see, the context to make our decisions. So why don't we do that with science? And I'll leave it with that.